Okay, let's wait a minute. So, how was the midterm? Did everyone do okay? Yes. I didn't look at it, so, but I would think it's. I don't think he would make the questions that hard. Okay, and just a reminder, the home for quiz 4, question 3, it should be false. Yeah. So remember, continuity is like limit from left being equal to limit from right. That just means limit exists, right? But continuity is more, right? Its limit exists and it's the value like of the point at of f at a, right? So it's a bit more. So I'm gonna tailor today's. So today, well, I'm gonna go over chain rule, and I'll sort of tailor some extra stuff to the homework. So your homework is up, homework 5. So let me just say for homework 5, I'll just say look at previous videos. Um, but I did go over an example of what it means for like a horizontal to have a horizontal tangent. So let me just say horizontal tangent means derivative is 0, right? So hopefully you all know that like I post the videos on the YouTube channel. So if you just go to files and then like Matthew's Zoom link, along with the Zoom link, there's like a link to the YouTube channel. Okay, but yeah, so to answer homework 5, just know that horizontal tangent means derivative is 0, right? And like if you have a graph, right, it's pretty much wherever your slope is 0. So you could look at, so think of it like the top of a hill. So like something like this, right? Is whenever your tangent line is horizontal, right? Or bottom of a hill, if you like, right? It's whenever like your slope 0. Okay, and the other thing is if you recall, there was like a special limit, right? Limits. That's also in the previous discussion video. I went over that limit. Theta goes to 0. Sine theta over theta is 1, right? So you're gonna be needing this to solve like a limit, because I think, let me just do an example for you. If you didn't know this, right? X goes to 0. Sine of 20x over 17x. So here, right, what happens if you plug in 0? What do you get if you just plugged in 0? Yeah, 0 was 0, right? Not gonna work. So instead, like, right, well, if you get 0 over 0, you know there's some like cancellation or some like algebra you have to do, right? In this case, it's not obvious because before, like, when you got 0 over 0 for like polynomials, what would you do? You would factor it, right? Here you can't really like factor sine, so we basically use the special limit. So no, it's good. We're going to 0, right? We're going to 0 here. And basically, if I have the same input compared to the bottom, right, it's 1. So, but right now, I don't have the same input, agree? Like if the bottom was 20x, it would be great. But then the limit's 1, right? Does everyone agree so far? Or like if it was sine of 17x over 17x, or like say sine of 20x over 20x, either way, the limit would be 1. Everyone follows so far. So like the data doesn't really matter. Like it could have been sine. So I'm saying like from here you get that sine of 2 theta over 2 theta is also 1. Like, right? Because it holds for like anything going to the 0, right? So that it should also hold for like just anything of the same input. So we're gonna make use of this. So let's make it the same input. So, and basically you multiply by 1 in a very smart way. So here you get 20x over 20x, right? So limit x goes to 0. So I'm going to group it 2 ways, right? This is sine of 20x over 20x, and then times 20x over 17x, right? So these cancel. So I get 20 over 17 limit x goes to 0 sine of 20x over 20x. So what is this limit? Using the thing up here. What is this equal to? So my input's the same now, right? So I have 20x and 20x here. So what does the special limit tell me? So this should be 20 over 17 times 1. Yeah? Everyone clear on this? Yes? No? Uh, yeah, and I think it's not on your homework, but there's like a second special limit with like cosine. So make sure you know that too. So just refer to the previous videos. Okay. So today I'm gonna go over chain rule. So so we know how to take derivative of how to when you add functions, multiply functions, divide functions, right? So the last thing is composition, right? So this is just formula for derivative of composition. So basically, what is derivative of this? Yeah. So what's derivative of f composed g? So this by derivative I mean of the whole thing. Well, this is chain rule. It says it's f prime of g of x times g prime of x. Yeah. So let me just say this is mathematically. Formally, you would say that the way you should think of it is think derivative of outer plug in inner, right? So that's the first term. Plug in inner, and then multiply by derivative of inner. By like outer and inner, you should think like the outer function, inner function, right? So here, right? And then let me just say there's an extra derivative rule. I forgot to say this last time, but I mean before, but we know derivative of e to the x is e to the x. So this is it turns out in general, it's b to the x ln b, right? So no, this doesn't contradict this, right? Because here, this is e to the x ln e. And what's ln of e? Yeah. So note, it still agrees with the original thing, that derivative of e to the x is e to the x. Okay. So I'm gonna maybe go easy to hard. So let's practice chain rule. So today we'll be practicing chain rule. Okay. So let me just say all my examples are basically find f prime of x. Let me use h actually. H prime of x. When h of x is e to the root x. So let's do this first. Okay, so this is, let me just tell you, a prior, I mean, it might not be, but let me just say it is composition. E to the root x is a composition of two functions. So my question to you is, what is f and what is g in this case? Right, how do I compose, what two functions do I compose to get e to the root x? So this is the hard part actually. If once you get this, you just follow the rule. Yeah. So you should think of it like the outer is not e, right? It's e to the x. Yeah. I mean it can't be e, or because if you do f compose g, right? This is just e, right? I'm plugging in root x to a constant function. That's just e. Yeah. So it should be e to the x, right? And then you could check that f of g of x is e to the root x. So once you have this, it's just a formula, right? It's f prime of g of x. So it says that the derivative, right? How many parentheses do I have? Derivative is f prime of g of x times g prime of x, right? So let's find f prime of x first. What is f prime of x? Good. Now, I don't want f prime of x. I want f prime of g of x. So what's f prime of g of x? No. Okay. As we start, yes. So yeah, I thought you were saying the same thing as f prime. So just a refresher, this might look scary, but really, like if you just think of, if I asked you, what is f prime of 1? What would you all say? It sounds like a dumb question, but what would you all say if I asked you what's f prime of 1? I mean, this is f prime. What? Huh? No, it's not 0. Huh? No, it's not 1. I mean, you plug in 1 for x, right? It's e to the 1, which is e. Yeah. I think you're thinking ln of 1. So ln of 1 is 0. So what did you do? This thing you plugged in to x, right? So just same exact thing. Instead of a 1, you have a g of x here, right? Same. You do the same exact operation. What did you do? You plugged in 1 for x. So here, what do? You plug in g of x for x, right? You plug it in for this x. And g of x is root x, right? Okay. So here, now second question, what's G prime? Again, so I'm asking for a derivative of this. Yeah. Some people prefer to write it like this, right? So this is your answer, right? It's, whoa, it's 1 over 2 root x. I'll write like this. I'll write this first. So e to the root x times 1 over 2 root x. Yeah. So you can see what I mean by the English, right? So if you read this part, right? Derivative of outer, plug in inner, multiply by derivative of inner. Yeah. So really quickly, right? What's the outer function? It's exponential. What's derivative of outer, right? Of outer is e to the x, right? Because derivative of e to the x is e to the x, and then plug in the inner function, right? So that's e to the root x, right? And then derivative of inner function is 1 over 2 root x. Yeah. So, but you know that this is like not formal, right? It's just the way to think of it is like that. But this is the formal way to do it. So I'm doing it like this, right? Because this is the beginning, right? We just went over it. So I don't expect you like on homework to write, you know, to write this all out, right? Eventually you should be able to do it like without writing this all out. You could just look at this and say, oh, it's e to the root x times derivative of root x. Yeah. But for now, for today, we'll go slow. Okay. So next problem. What about this? This is a 1, by the way. So plus 1. So again, I'm saying is f of g of x. So, you know, it's a composition of two functions. So what is my f? What is my g? Yeah. Think of the outer as like the outside thing, right? So the outside thing is your square rooting, right? So, and then the whatever is inside is x over x plus 1. Yeah, so you could check that f composed g is this. So this is the hardest part, really. Like once you know this, the rest is just formula, right? So the derivative, right, f of g of x prime is, again, it's just this, right? And then from here, it's just, you know, just write it out. Same exact thing. Find f prime of x first. So derivative of f prime, I mean, we went over this in the previous example. It's this, right? So just testing you. What is f prime of g of x? So again, if this confuses you, just think of f prime of 1. What do? You do 1 over 2 root 1, right? If I ask you for f prime of 1, you plug in 1 for x. So here you plug in g of x for x. Yeah. So this is 1 over 2. What's g of x? It's x over x plus 1. And now how do I find g prime? So how do I find derivative of this? Quotient rule, good. So this question is a combination of chain and quotient rule. Yeah. So I don't know if you were here in my discussion last time, but like because midterm didn't cover chain rule, like a combination of quotient rule and product is not that hard. But once you introduce chain rule, it gets a bit more difficult, right? It looks a bit more weird. Like you need to know what you're doing. So here, right, it's quotient rule, right? X plus 1 squared, and then derivative of x is 1. So x plus 1 minus x. So this is just 1 over x plus 1 squared. Yeah, so your final answer is this. I mean, you could, if you like, you could simplify this, but this is the answer. Yeah. So you can expect from on your final or something, right? You're gonna be, they might do like chains of quotients of products of chains, like chain, just a whole mess of like combination of these rules. So you should be prepared. So let's do something harder. So h of t is e to the t sine of 2t. Again, I'm saying this is, there's two functions such that when you compose, you get this. What are my two functions? So by the way, I'm making the examples harder and harder. Yeah. so like, I started easy and then I'm gonna go harder and harder to like, so all of you see everything. So like nothing surprises you on like on the final. So here, what two functions do I compose to get that top function? So think of the outer function as the main thing, like the main thing this function looks like, right? Like if you go back, right, the f here, the main thing was your square rooting. So f was square root of x, right? Here, the main thing was exponential. So f was, the outer function was your exponential. So here, what is the main operation that's happening, or main function that's happening, if you understand what I mean? So that should be your outer function, whatever's happening on the outside. Good. E to the t, right? And you don't really have an option for, yeah, right? So derivative of this, right? How many parentheses do I have? Is again f prime of g of t times g prime of t. Now, I made this hard for a reason, but let's see why it's a bit harder. So what's f prime of t? This should be easy. Derivative of e to the t. So derivative of e to the t should just be e to the t, right? Nothing changes. So now again, here I'm plugging in g of t for t, right? So it's e to the g of t, which is e to the t sine of 2t. So that part's easy. Now, here comes the harder part. What's g prime of t? What rule am I using now to find this? Product rule. Okay. So if so derivative of let me just say let me write it like derivative of t is 1, right? So this is sine of 2t. And then I'm adding whatever derivative of sine of 2t is, right? Times t, right? It's product rule. Now, how do I find derivative of sine of 2t? So again, you don't know this, right? You only know derivative of sine t, right? Derivative of sine is cosine. So derivative of sine t is cosine t. And you know derivative of 2t is 2, right? So what rule am I using to find derivative of sine of 2t? So I want to find this, right? So I know derivative of sine t is cosine t. So these individually I know, right? So again, what rule am I using? I made it a bit tricky for this reason, but so again, let me give you a hint. This is f1 of t, f1 of, I'm saying there are two functions that compose. I'm running out of, letters, so I'm using f1, f2, that compose to give sine of 2t. What are my two functions? So my outer function, what does the main thing that's happening for sine of 2t? What's my outer function? Sorry, the t looks ugly. So what does this? What's so sine of 2t? What's mainly happening? Like, what does the whole function look like? It looks like sine, right? I mean, you don't really have any choice. So here it's another chain rule, right? It's sine t and then compose 2t, right? You could check that f, when you compose, you get sine of 2t. And I'm not gonna write this out, but derivative of sine's cosine, right? So it's cosine of 2t. Sorry, it's cosine of t. Derivative sine's cosine. So this is cosine of t, but then I plug in the inner, right? So that's cosine of 2t times derivative of 2, which is 2. Yeah. So I'll let you check that, use chain rule to check this is the derivative. So, do not just say this is cosine of 2t. Yeah. It's cosine of 2t times 2 because of, the 2t inside. You need to chain rule it. So this is equal to sine of 2t plus 2 cosine of 2t times t. And you just combine it, right? So your answer is e to the t sine of 2t times this mess times sine of 2t plus 2t cosine of 2t. Yeah. So this is an example of chain rule of product rule of chain rule. Something like that. Yeah. So 2 chain rules and 1 product rule. Everyone good so far? Like, yes. So in the end, it's just break everything down to like all the rules, if I'm gonna summarize. Yeah. Okay. So let's do 2 more and then I'll switch to different examples. So this is something you'll see a lot. So I think this is on your homework too. But I'll exaggerate it. Yeah. The homework puts it to like, plus 3x squared minus x. So your homework was nice. I think your homework has like something cubed times something to the fourth power. So, you don't want to multiply that all out, right? Whenever you have like, like here, you don't want to multiply this 50 times, right? Like that is ridiculous. So on your homework, I think it was total to the seventh power because you have something cubed times something to the fourth. And still, even in that case, you want to use chain rule. You, you don't want to multiply everything out. So I exaggerated here in this case. So again, there are two functions that when you compose, you get this. What are the two functions? So the outside function is what? What does this whole thing look like? What's happening as a whole? You're raising something to the 50th power, right? So this should be x to the 50. I think on your homework, your outer function would be like, when you use product rule, your outer function would be like some x cubed or like x to the fourth. And then my g, right, is x to the fifth plus 3x squared minus x. Right, so derivative, chain rule tells me derivative is f prime of g of x times g prime of x. So again, step by step, f prime of x is derivative of x to the 50, right? So this is 50x to the 49, right? 50 minus 1. Now, I don't want f prime of x, I want f prime of g of x. So again, plug in g of x for x, right? So this is 50x to the fifth plus 3x squared minus x to the 49th power. And then g prime of x. Well, this is easy, right? You're just doing the power rule 3 times. So it's 5x to the fourth plus, bring the 2 down, that's 6x minus 1. So this is your answer. So you see here, this is way better than multiplying 50 times, right? Like, you could multiply 50 times, you'll get the same answer. But this, yeah. Everyone clear so far? Yeah, chain rule is a bit harder because it's harder to spot, right? If you're multiplying and if it's just product and quotient, you see it. You're multiplying or you're dividing. But like chain rule, you have to realize, two things are being composed. So let's do a last one and then I'll switch topics. Switch question type at least. So h of x is tan of secant of cosine of x. So this is obvious composition, right? I mean, I'm not multiplying at all. I'm not dividing at all. I'm not adding at all. So, right, like nothing's happening but composition, right? So you can see that this is, I'll do the first one for you, right? This is just the outside one is just tan x, right? My g of x is secant of cosine of x. And then, so you could check that, when you compose, you get tan of secant of cosine of x. So again, this is chain rule. Sorry, this should be on the outside. So hopefully this should be clear by now. So derivative of tan, that's something you should memorize, right? It's secant squared, right? So f prime, so this this is just memory. And then f prime of g of x, well, I'm plugging in, g of x for x, right? So this is secant squared of secant of cosine of x. Now, here comes the hard part. How would you find g prime of x? Right, because I found this term. Now I need to find this term. So how would you find derivative of this? So just tell me, like, what rule should I use? So it's secant of cosine. Yeah, it's another chain rule, right? So this question, it's two chain rules. So I'm not gonna write I'll skip some steps, right? So derivative of secant is tan, secant tan, right? So secant tan, then I plug in the inside. So secant of cosine, tan of cosine, right? And then I multiply by the inner, right? I multiply by derivative of cosine, which is negative sine. So your final answer is this, times secant of cosine of x, tan of cosine of x, times negative sine x. Okay. Yeah. That's all the examples I want to show you, right? So on the final, I mean, the only way he's going to trick you is, combining rules. And so I did like many examples of, like, combining product rule with chain rule with chain, stuff like that. So if you need more practice, just go to the book. Yeah, they have plenty. Okay, so moving on. So I noticed it's not on your homework this time, but, like, I noticed they ask a lot of, like, how do I say it? Like pattern questions, right? Like find the nth derivative. So let me just do one here using chain rule. So find the 50th derivative of cosine of 2x. Let me just say that this is h of x. So let's find the first derivative, yeah? This is, sorry, equals. So before I continue, right, you should know that eventually you'll end up with, like, some multiple, right? Because if you notice, what's derivative of cosine? It's sine, right? Or sine with, like, negative, but you should just think of, derivative of cosine is something sine, right? Derivative of sine is cosine. So you see, like, after 2 times, right, I basically get some cosine back, right? So you can sort of see, like, eventually there's going to be a pattern. So what's the first derivative? Well, this is chain rule, right? Everything here is chain rule, right? Derivative cosine is negative sine, right? And then I plug in the inside, right? So my inside function is 2x. And then I multiply by derivative of inside function. So that's 2. So again, so let me just say, for this one, your outer function is cosine, right? Your inner function is 2x. Yeah. And then, so apply chain rule. Now, the second derivative is what? Well, the 2 doesn't matter, right? The 2 just stays, right? So that, like, it's 2 times, well, what's derivative of this? Well, derivative of sine is cosine. So it's negative cosine of 2x, right? And then I multiply by another 2 because of, because of the inner function, right? So here, my f of x is negative sine x. And then my g of x is 2x, right? So it's chain rule again. So this is 4, negative 4 cosine of 2x. Now, you'll see once you get to H4. So once you get to H4, right? I mean H3. Yeah, H4. So H3, right? Same exact thing, right? So here my f of x is cosine of x. Like the -4 doesn't matter, right? You just pull it out. G of x is 2x, and then you'll get that it's 8 times sine of 2x. Yeah. So I'm leaving this for like you to check. So for you, so you could practice chain rule. But and then here you're gonna get 16 cosine of 2x. Basically, what you're gonna see is, this is 2 to the 4th. This is 2 cubed, right? This is 2 squared, and then this is 2, right? So you can see that H50, if you see the pattern, there's gonna be a 2 to the 50, right? And now I started off with cosine. I went to sine. I went to negative sine, right? So I went from cosine to negative sine, right? To back to negative cosine, and then back to went from cosine to negative sine to negative cosine, and then to sine, negative sine, positive sine, and then back to cosine, right? So this was just H, this was H1, H2, H3, H4. So every 4, I go back to cosine, yeah? So I know that at H48, this is a multiple of 4. So it's going to be cosine, right? And then you just do the pattern. So H49, cosine moves to negative sine. And then H50, negative sine moves to negative cosine. So this is negative cos. So I'll put the negative outside. Negative cosine of 2x. Yeah. So this one was a bit harder. I should have done like e to the x for like to make things simple. But hopefully you all see like what's happening, right? It's the same. I think I went over. It's the same thing as here, right? Right here. When in my example, when I took derivative of sine of 2t, right? Same exact process. So on Thursday, I'll go over because your homework. The only thing, and you should be able to do all of your homework except for implicit differentiation and derivative of like inverse trig functions, which is like the last 3 problems on your homework, I think. So, but you should be able to do the rest. Yeah. Any questions? So I'll go over implicit stuff, on Thursday.